Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over equation stoichiometry and focus on mole ratios as conversion factors. So let's get into this. Whenever you're doing equation stoichiometry or stoichiometry in and of itself, you need a balanced chemical equation. The reason that you need a balanced chemical equation is because in stoichiometry, you are converting from one substance to a different substance. And so you using a balanced equation, right? So you're using a chemical reaction and you want, say, if you're given a certain amount of reactant and you're asked to give or figure out how much product could possibly be made from that amount of reactant. And so you're going to need a conversion factor that allows you to convert from moles of one substance to moles of another substance. So we need a mole ratio. So in previous videos that I've done, we've used the mole ratio using the formula of the compound we're interested in. At that time, we were focused on converting from moles of the compound to moles of an element in that compound, right? But in this case, we're converting from one compound to a completely different compound or species or element based on a chemical reaction that's occurring. So what we need to get our mole ratios is the balanced equation, and the mole ratio is going to come from the coefficients in the balanced equation. So when I have a balanced equation like this here, so these two substances react to form this substance. So if I want to convert between any of these substances, so if I'm given a certain amount of this substance here, and I want to know, well, how much water do I need to make that amount, or how much of this substance, tetraphosphorus dicoxide, would I need to produce that amount here, or maybe how much of this do I need to react with this? Any of those questions require that you convert from one substance to the other, and we need a mole ratio. Remember, whenever you're converting from one substance to a completely different substance, you got to go through the mole ratio. You have to use mole ratio at some point. It's in your conversions. So the mole ratios, when you're doing stoichiometry, the mole ratios are going to come from the coefficients in your substances. So any of these matches here, anything that you match together could be a mole ratio. So we can put these two together as a ratio. So 1 mole of this substance requires 6 moles of water to react completely. So I can write that as 1 mole of P4O10 over 6 moles of water, H2O. Let's use the abbreviated form of moles. So there is a mole ratio of moles of P4O10 to H2O. And it came directly from the coefficients. Or I could do 6 moles of water to 4 moles of H3PO4. So I can write 6 moles of water to 4 moles of H3PO4. Okay, so there's another mole ratio I could use. Another one would be if I relate this substance to this substance. So it's going to be 1 of these will produce 4 of these. So then that's another one. So I could do 1 mole of P4O10 over 4 moles of H3PO4. So here are 3 ratios, mole ratios, that I got from my balanced equation. And I can use any 3 of these to convert from one substance to the other. So if I'm asked to convert moles of a given number of moles of my P4O10 to a given number of moles of my H2O, or I can flip that. If I'm given a certain number of moles of H2O, right, and then I want to find a certain number of moles of P4O10 or P4O10, then I can use this mole ratio as a conversion factor to convert from moles of water to moles of P4O10. Or if I'm given a certain number of moles of H3PO4 and I want to convert that to moles of water, I can use this mole ratio as a conversion factor to convert from H3PO4 to moles of water, H2O, right? And the same thing for this mole ratio here. It just depends on what I'm given and what I need to look for, okay? And not only do I have these, but I can flip these to get new mole ratios. So I can flip this and I'll have 6 moles of H2O over 1 mole of P4O10, right? So I can use this inverse ratio. This ratio here I can use if I'm given a certain number of moles of P4O10 and I want to find a certain number of moles of water from that amount of P4O10, or the amount of in this case, since they're both reactants, the way to describe it would be if I'm given a certain number of moles of P4O10, the question would be, well, how many moles of water would I need? And then I would use this as a conversion factor to convert from moles of P4O10 to moles of water. And I can flip these as well. So the point here is that from your balanced equation, you get the mole ratios directly from the exponents, sorry, not exponents, from the coefficients in your balanced equation. And so you just use those coefficients as mole ratios, and then you've got your conversion factors. Now, one more thing before I end, you'll notice that you have 4 and 6 here. That can be reduced to 3 and 2. I don't really like the reducing. I would just rather just keep the numbers the way they are from the coefficients that you got, and just let your calculator do the simplification for you. The reason is because if you simplify, that's another step where you can involve error. Maybe you simplified wrong or whatever the case may be. I would rather avoid that possibility and just plug in the numbers they gave you. So 6 and 4 is what I would plug into my calculator and let my calculator just do the simplification in of itself. So why do the extra step of simplifying if you don't need to? But hey, if you want to simplify it, you can, as long as you just make sure you have the right numbers after you simplify. That's it for this video. I hope this was helpful. If you enjoyed this video, then please like the video, hit that like button, share the video with your friends. Make sure you subscribe to my channel. And when you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, if you have a particular question or problem that you want me to help you solve, I would love to do that for you. Thanks for joining me and have a great day.